percentage yield for AQA GCSE Chemistry. So we'll start with the idea of maximum theoretical amount. Then yield or actual amount, the calculation of percentage yield, and then some exam style problems which I recommend you work your way through. Maximum theoretical amount is the maximum amount of product calculated to form in a complete reaction. So if we look at an example, the maximum amount of ammonia, NH3, produced by the complete reaction of 6 grams of hydrogen. Well, we can calculate that in the normal way from a balanced chemical equation. So we have a mole ratio of 3 moles of hydrogen to 2 moles of ammonia. We're starting with 6 grams of hydrogen. We convert that into numbers of moles by dividing by the molar mass 2. So 6 divided by 2 is 3. We're starting with 3 moles of hydrogen. Well, the complete reaction of 3 moles of hydrogen will produce 2 moles of ammonia. That's the maximum amount of ammonia in moles. But it's convenient to convert that into numbers of grams. So the mass of 2 moles of ammonia is 2 multiplied by 17, comes to 34 grams. That is the maximum theoretical mass of ammonia that could be obtained. So from the balanced chemical equation, predict the maximum numbers of moles, convert that into a maximum amount in grams. So now just to clarify the meaning of yield or actual amount. Using the balanced reaction equation, we can calculate the maximum theoretical amount as we did on the previous slide. But the calculated maximum mass of product may not be obtained for a number of reasons. AQA lists 3. For example, the synthesis of ammonia. This is a reversible reaction. A certain proportion of product, once formed, converts back into the reactant, so the maximum theoretical amount is not obtained. Alternative reactions may produce byproducts. For instance, propene and steam will react to form propan-2-ol. However, there is also a small amount of propan-1-ol produced of the byproduct. So calculating the maximum theoretical amount of propan-2-ol, that mass will never be obtained because there will always be at least a small amount of propan-1-ol formed as well, a byproduct. Practical procedures may result in the loss of product. The third reason, for example, preparing pure copper sulfate crystals, the final step is washing and drying. Well, that must result in some loss of the crystal product. So for these reasons, the maximum theoretical amount of, say, product C may not be obtained. The actual amount of product that is measured to have been made is called the yield. So we have the maximum theoretical amount, that's a calculated value based on the balanced chemical equation and the starting amounts. The actual amount of product that is measured to have been made is called the yield. Of course, that measurement could be in grams, it could be a volume of gas, it could be a volume of solution. All of those properly converted into numbers of moles. But at AQA GCSE, the focus is very much on measurements of yield in terms of the mass of the product. Calculating percentage yield. Percentage yield is a numerical comparison between the actual yield, and the maximum amount. AQA specification expresses this as masses. So the percentage yield is the actual mass of product divided by the maximum theoretical mass times 100. Let's look at an example to clarify. If the actual yield of ammonia in a reaction of 6 grams of hydrogen was only 11 grams, rather than the maximum theoretical mass of 34 grams, and we calculated this 34-gram figure earlier in the class, well then the percentage yield is the actual mass, which is 11, divided by the maximum theoretical mass, which is 34. So 11 divided by 34 times 100 gives us a percentage yield of 32.4. So I have two problems on this slide. Both of them are by far the most popular exam style questions used by the AQA. So problem 1, calculate the percentage yield for a reaction in which 6.6 kilograms of iron was obtained and for which the maximum theoretical amount was calculated to be 10.6 kilograms. Pause the lesson, calculate percentage yield, check your answer when you're ready. Okay, so percentage yield is actual divided by maximum theoretical times 100, 62.3. Now the second most popular question is where you are given, for instance, a maximum theoretical amount and then the percentage yield. So a sample of zinc sulfate crystals prepared by reacting zinc oxide and sulfuric acid. The maximum theoretical amount of zinc sulfate crystals formed was calculated to be 114 grams. If the percentage yield for the process was 96.5, calculate the actual mass, the yield of zinc sulfate obtained. Pause, see if you can solve that problem, come up with the actual mass of zinc sulfate crystals formed. Restart when you have your answer. Okay, so 96.5, that's the percentage yield, is the actual mass divided by the maximum theoretical. Now we don't know the actual mass, but we do know the maximum theoretical. So substitute in 114, rearrange and solve for the actual mass. Comes to 110 grams. So a far less frequent style of question is one in which you have to calculate the maximum theoretical amount from a balanced chemical equation and a starting amount of reactant, and then calculate the percentage yield. So here's an example. Calculate the percentage yield for the reaction below. Here's the balanced equation. Given that 16 grams of iron oxide produced 4.9 grams of iron in excess carbon monoxide. That means all of the 16 grams of iron oxide reacted. Can you solve the problem? What's the percentage yield? Stop the lesson, carry out the calculation, come back to check when you are ready. Okay, so I'll go through. The mole ratio between iron oxide and iron is 1:2. The numbers of moles of iron oxide reacting is 16 divided by the molar mass, 160. So that's 0.1. That would produce, as it's 1:2, a maximum theoretical number of moles as product of 0.2. So that's the maximum amount of iron in moles. Let's convert that into grams to give us the maximum theoretical mass of iron. So 0.2 times 56 comes to 11.2. Percentage yield, well, we know the actual amount, 4.9, divided by the maximum theoretical mass, which is 11.2, times 100 comes to 44%. Congratulations if you got that right. Well done for finishing. If you want more practice, try textbook questions and then past paper questions. For more related classes, look at the playlist or links in the video description. If you found this lesson helpful, please recommend it to a friend. Subscribe for new classes and last-minute exam tips. Likes and comments are always appreciated. Thank you.